I think we can start the workshop. So I would like to thank everyone for joining today, especially our ICT 56 representatives from the other projects. Thank you very much for giving us the opportunity to have a discussion together towards the finalization of our projects in the ICT 56 cluster. I hope you can hear me well. I am Anna Trentafilou. I'm from the University of Western Macedonia, which is the coordinator of the Terminet project. And we're having this meeting together with our dissemination manager in Terminet, Theodoros Zokas from Insights. So we can begin based on our agenda. I think we have here representatives from and speakers actually, keynote speakers from the project. So I think we have Nuria here from Ingenious, right?
Yes.
Thank you. Great. We have a representative from IoT Engine.
Yes, Ilkka Lakanimi from Aalto University here.
Hello, thank you. From EdgeCloudIoT.
Yes, hello, Konstantinos Sarakis from EdgeCloudIoT.
Hello. I will be representing Terminet. I think we saw Jens from EdgeCloudIoT.
Yeah, there seems to be a problem with unmute. So I guess you can hear me now. So this is Jens Hagemeyer from Bielefeld University. Nice to be here.
Thank you. And from Assist IoT? Assist IoT. I don't think anyone has joined yet. But let's move on with the agenda and we shall see as we go on, so as not to delay any further. We can start the keynote presentations with Nuria from Ingenious. So when you're ready, Nuria, please go ahead.
Sure. Let me share the screen. No, I cannot. You should give me permit or something, because I cannot.
Just a minute to check it. Now?
Now I can, yeah.
Okay.
Let me know if you see. Okay.
Yes, we can see the presentation. Perfect. Now not.
Now you should see better.
Yes.
Okay, is it the right mode of presentation?
Yes, it's perfect, yes.
Okay, so I'm Nuria Molner. I'm a researcher here in the Technical University of Valencia, and I have been the deputy project coordinator of Ingenious. I say I have been because you should know this project finished last March, and we had a successful final review last July here in Valencia, a very summer day, as Stefano can confirm. So I'm going to present the project and how we have focused on the standardization aspects.
Yes, I confirm, by the way.
Okay, I cannot change the slide. No, okay. The Ingenious project was composed of a consortium of 21 organizations from all Europe, and we had an external advisory board of 9 different organizations to, let's say, interact with us, so we are aligned with the industry and what everyone expects from these projects. And as fact sheet of the project, the Ingenious targeted to automatize and digitalize the end-to-end supply chain, leveraging the 5G technologies, edge and cloud computing, and artificial intelligence. We did some proofs of concept and some demos in 4 testbeds, real environment testbeds, as they were the Port of Valencia, the Port of Livorno. We also sent a Costco ship from the Port of Valencia to the Port of Piraeus in Greece and back. and also from Valencia to Madrid by train, a container that we sensorized for a use case that I will explain later, and also a factory of a robot manufacturer in the north of Spain. Since the ambition of the project was big, we divided the work into 6 different use cases covering the whole supply chain. So the first use case was the factory use case, then second one would be the transportation use case, terrestrial transportation, then the port entrance use case, and inside the port, we targeted the remote driving of AGVs. And then the ship use case, that is what I said, that we sent a ship for the monitoring of assets by the sea. So we use satellite connectivity there. And the 6th use case is the DLT use case, covered, let's say, all the previous use cases, as it ensures the secure exchange of information among devices and to the cloud and edge computing. Okay, the different use cases were targeting several challenges. The first use case was intended to orchestrate the 5G industrial networks and ensuring a smooth end-to-end management. The second use case intended the defect detection using machine learning-based sensors trained on real-world data, using low-power IoT connectivity. And the port entrance use case intended the data accessibility and machine learning model development to predict and optimize track turnaround times and container traffic in ports. The AGV use case was intending to the remote driving inside the port. So by remotely driving robots, workers could avoid the hazardous areas in the port. It extrapolates to other environments, but we did it inside the port of Valencia. And the 5th use case, the ship one, intended the end-to-end tracking and real-time monitoring of shipping containers and assets, both in land and sea. And the last use case, the main challenge was the virtualization of machine-to-machine platforms for unified data access, which means that the IoT devices, as you know, use different protocols, so it's very difficult to actually communicate among them or extract information from all of them. So we intended to develop a virtualization layer that can, let's say, translate and extract information from all of them and ensure that this information is transmitted in a secure way. So this is very ambitious. So we designed a cross-layer architecture composed of 4 layers. The lower layer would be the things, what we call things layer. That is the IoT devices, sensors, actuators, and let's say all, devices we interact with. Then it's the network layer, the management and security services, and the smart applications. 2 aspects that covered all the layers would be artificial intelligence and machine learning models, and security and privacy, as we needed to ensure security at all levels and extract, let's say, information and automatic orchestration of our layers with artificial intelligence. And we built our architecture based on existing standards, but as not everything is done, and that's also the purpose of these projects, is that we built over what is existing and it's useful, but we also evolved and tried to contribute to the standards organizations with our results. And in particular, some partners were monitoring and actively contributing to the SDOs. As you can see here in the slides, we have been working with 4 SDOs actually, and we managed to contribute with 38 reports of our activities. And well, as challenges in these organizations, let's say, it's that it's very difficult for these projects with managing so many technologies. It's difficult to contribute to follow a specific standard or to contribute to them, as it's a very challenging environment. But we manage, and we should all keep trying to push there because we have things to contribute on and evolve what is already done. And well, as last challenge, which would be more like next step for future projects, would be like for 6G standardization, it's necessary to consider a joint design of the whole IoT continuum, IoT Edge Cloud Continuum. So that would be my presentation. And if you have any question, please go ahead.
Thank you, Nuria. Sorry, Anna, you want to talk?
No, I thank Nuria for her presentation.
Okay, if you have any comments, questions, or something, please, now's the time. Okay,
Maybe a question from my side. This is Jens here from EdgeCloudIoT. How did you manage to contribute to the standards? Because, for example, in our case in EdgeCloudIoT, we didn't contribute to, let's say, as many standards as you did, but let's say the interaction was quite close and quite let's say time consuming, because we had like weekly meetings over, let's say, the full project period and so on. Was it also that you were, let's say, like deeply involved in the different work groups, or was it more like you make a suggestion to some of the committees and then they got back to you?
No, we had like 5 partners that are still actually very involved in the standards organizations. So what we were developing in the project, they would push those contributions in the meetings they are attending. It's not that we as a consortium go there, but the partners that are already involved were like representing us there.
Okay, thanks.
Okay, we have a question regarding the presentation files and the recorded video. So we will upload them to at least to the Terminate website after the end of this meeting, when we collect all this information. I think I can send you, so you can check the Terminate website. I don't know if the other projects will also like to put that in their websites. So that's a place where you can find all this information. Okay, I will contact the authors to gather all the presentations. And I think I can send an email to all with the link. Okay. Okay, I will write here in a couple of minutes the website. So let's continue. So we go to the next presentation to IoT NGIN. You have Ilka. Let me give you the presenter. Right, just a minute. I cannot find you here.
I'm here. So.
Okay, I find you.
Very good.
Now you can present, I think. Okay.
Thank you.
Thanks.
Okay, you see it okay?
Yes, perfect.
Okay, perfect. Many thanks for the kind invitation to the meeting. And even if, like in the previous presentation, the IoT Engine project has officially ended, a lot of the tasks related to outreach and also standardization are actually continuing at the kind of a work in progress with the participants in the project as such, myself included. So this is the consortium that we had. Among the participants, you see there are large enterprises, research organizations, small and medium-sized enterprises, and also public sector organizations like Forum Virium Helsinki, which is owned by the city of Helsinki. Out of the participants, there were companies like Ericsson, for instance, that are very deeply into the 5G standardization activities taking place and activities. And like was asked before, that helped us and supported our activities that we had. Not only Ericsson, but the others also that were taking already active participation in the standardization to get the IoT engine outcomes interlinked with the standardization work. We had meetings every month, so a monthly meeting for the standardization that was chaired by the Aalto University, and most of the project participants took place in those meetings. IoT engine itself brought together different technologies, which I myself called combined effect technologies. So for instance, when we had use cases and individual discussions with companies outside of the project consortium, we could showcase to them that we are actually working on not only on 5G, but on AI, on machine learning, on digital the ledger technologies, so the blockchain type of activities as well, and that mattered greatly. So basically, we were addressing IoT in general, and actually got a lot of traction from that type of approach as such. We were also offering the companies outside of the project and the use cases new services to their existing platforms, so that it didn't come totally as a novel idea to them, but it actually complemented their activities in many of those areas in the use cases like smart manufacturing and smart cities, and also smart agriculture to that matter. So the collaboration was very hands-on, and we were able to have a kind of a concrete discussions with the project participants and also the external parties taking place in this. And during the second phase, we actually put a lot of effort on creating the business potential for IoT engine to live on, so that there is a sustainability model for after the project ended. And that's what I referred in the beginning. We are continuing to have discussions with individual companies and also consortiums of companies how to continue to use the outcomes of IoT engine as such. And there were specific items that are currently kind of taking place of several discussions and company offerings to that matter. Mainly, I would say that very briefly, I will showcase to you that what it is that we were actually doing, and then I will focus on the standardization activities as such. So we had altogether 7 work packages really looking into the technology as advancement and achievements within the IoT engine. And then we had a work package dedicated that I led on the business modeling and the sustainability aspects of the IoT engine as such. But from the technology point of view, you can see that from the work package 1, we were really setting up the scene and the meta architecture for the use cases and the technology development take place. We had a work package working on the IoT underlying technologies. We were looking into the machine learning and how to create a machine learning as a service type of a platform for the use cases, but also for outside of the project consortium discussions. We were looking into tactile and contextual sensing, especially in the smart manufacturing environment. We had a specific work package looking into the cybersecurity and data privacy topics that were extremely important in a case of, for instance, looking into the private sector companies, how to enable use IoT for their specific business challenges, but also, for instance, how we could achieve a direct link to some of their client demand aspects as well. And cybersecurity was by and large one of the key topics addressed by them. We had integration activities that how do you take then the solutions coming out from the IoT engine project and how the path to the other initiatives currently taking place and also outside of the EU project activities, we were able to build on that side, and especially on the 5G area, the optimization of using 5G, for instance, for smart manufacturing cases were really, I would say, kind of the key assets that the IoT engine was able to do. Then we had use cases that were put in here in the work package 7, and all of the use cases that we had utilized the innovations and the solutions coming out from the IoT project itself, but also, like I said, combined our expertise and technologies to the other existing platforms. And this was specifically true in the smart city case, where the smart city consortiums and some individual cities have already invested quite heavily in different technology platforms, and they wanted to have interoperability between ours and them, theirs working for the future as well. And specifically on the standardization, like I said, we were supported by the fact that we had kind of a key companies as a part of the consortium working directly with the standardization and de facto standardization organizations. Myself, I was heavily in kind of working together with GaiaX and the Big Data Value Association activities in this type of a de facto standardization, which primarily means that we were not only looking into these kind of official standards, but we were looking at these kind of best practice cases that could be scaled and used by these associations and their member organizations for future business opportunities as well. But from the 5G point of view, we had successes in really getting our contributions accepted and published as global standards for the telco side, and from that side then obviously to the business markets. We had one startup called Twinbase that is actually now using and scaling the IoT project results to the market, and they are continuing to develop the IoT engine results as such. And then, as I mentioned, there was a strong industry interest from not only the existing project participants, but also industry outside of the project to look into how our solutions and our expertise could be utilized for their business benefits as such. So the collaborations continue and the discussions on that side continue as well. Here is a bit of a further detail that who were the partners that we were discussing with, and you can see familiar names from the EU circles, but also very kind of outside of the EU organizations and initiatives as well, and especially myself, I'm now involved in the cybersecurity discussions as such. Here is further information on that, and I will share all of this information so you can think that what were the kind of the key targets that we had. But I will then end my presentation and stopped sharing. And good. Am I still sharing?
No.
No. Okay. Very good. So happy to take any questions on that, and as I said, you will get a copy of the presentation. Any questions?
Okay, thank you. I don't see any questions. Maybe
Thank you.
after the presentation, we have some more questions. So we can proceed to the next presenter. It's Konstantinos Pisarakis from Intel IoT. Konstantin, I think you can share your screen now.
Yes.
Okay, thanks.
Let me share my PowerPoint. Yeah. You should be able to see it, right?
Yes, we see it, but we see not in presenters mode yet. Okay, it's all the whole screen. Okay, now it's perfect. Thank you.
So yeah, hello. So I'm Konstantinos Pisarakis from Sphinx Analytics, representing the IntelliOT project. Just a brief overview of the consortium. We are a consortium of 14 partners from industry and academia, though throughout the project, some partners, we collaborated with other entities through a couple of open calls that we held. Project actually ends this month. We expect to have our review sometime in March. You will see some partners from industry, academia, and some smaller SME partners across Europe. Basically, the motivation of EdgeCloudIoT was to, let's say, tackle some of the limitations of the cloud-centric IoT model, such as unreliable connectivity, limitations in bandwidth, limitations in round-trip times, especially for use cases like tactile interaction with devices, privacy and trust concerns, and so on. We basically proposed the reference architecture and framework to enable IoT environments for semi-autonomous IoT applications that evolve with the help of human in the loop as needed, based on efficient, let's say, both IoT edge and network computation capabilities, and the ability to dynamically adapt to the changes in the environment and the requirements of the use case, including security, privacy, and trust requirements. So this is just the basic concept there that we have. On the left, you have the various collaborative IoT applications working with autonomous or semi-autonomous agents. You can already see that we base this off the W3C Web of Things standards. Then you have basically at the right side, you have the actual assets of the different verticals. And then you have in the middle the human in the loop that can use AR, VR, and such technologies to intervene when needed and improve the capacity, the future capacity of the agents to tackle the different tasks, basically. We had 3 use cases: agriculture, healthcare, and manufacturing, always with the intervention of a human operator in different scenarios. You see basically on the bottom left, we have an autonomous tractor from AVL in Austria that we use to basically help the autonomous tractor do its tasks autonomously, and then intervene when there is, for example, an object that doesn't know how to surpass, and then help it. And the idea is that the next time it knows how to handle that situation. For the healthcare use case, we had a university hospital in Heraklion, Greece. Basically, there is also, let's say, a small quote-unquote trial with 20 patients that they use wearable devices to do various tasks, and there are like autonomous or semi-autonomous interventions telling them to exercise more and things like that. And then manufacturing, we have basically a robotic arm and some milling equipment that, again, you kind of let it go about doing the manufacturing tasks and only intervene when needed. I don't want to go into too many details, take up more of your time, but basically you see that we have, as I said, with these agents, there is, for example, in the agriculture use case, we have a farmer that defines the goal that is, I don't know, to go to a field and plow the field or something. The tractor should go about and do that by itself. If it faces a situation it doesn't know how to overcome, the human is has to intervene, and he remotely drives the tractor basically, and then the system learns from that, and next time it should be able to do it by itself. You see the healthcare use case with the wearables that I mentioned, and the interventions from clinicians were needed, because of course also in the healthcare use case we have the let's say the characteristic that you don't really trust a system fully autonomously to tell a patient to take a drug or something. There are cases where you want this human agency and oversight. Here we use also federated learning, where there is some training going on also on the mobile phone we distribute to the patients that participate in the trial. And then the manufacturing use case, where we have this robotic testbed working. Basically, you give it, the human defines an abstract goal that they want to mill, let's say, a certain image on a material, on a wooden piece of wood. The system is responsible for automatically finding the appropriate piece of wood, taking it to the milling machine, and when it's milled, it delivers it. And the human again is brought only when, for example, there is imagine like a very regularly shaped piece of wood that the machine doesn't know how to grab, and at first you have to train it where to grab it from. Speaking of the architecture, which we defined, basically what we did, we went through various iterations, but there is 3 main concepts in IntelliOT that we wanted to also highlight in our architecture. So you will see on the top side these 3 boxes referring to collaborative IoT enablers, i.e. The building blocks that allow the autonomous systems to operate basically autonomously and carry out the task by themselves. You have the human in the loop enablers that allow you to intervene and train the system as needed in the situations I mentioned, for example. And then the third pillar is the trustworthiness, and then you have all these enablers about the privacy and security and overall trust of the system. Of course, there are let's say the horizontal enablers having to do with the infrastructure management, both at the edge, at the cloud, and at the network level, with the use of 5G technologies and so on. And then at the very bottom, you have basically the edge environment. So the edge apps, the edge AI models, the actual sensors, actuators, and so on of the use case. I've already more or less explained the components, and then in each use case we had obviously different variants or subsets of this architecture that were applied. For example, differentiation was in one use case makes more sense to use VR glasses. In another, like in the agriculture use case you see here, we use the VR glasses to remotely drive the tractor, while for example, in the healthcare use case here, we use just the applications from the mobile phone. And in the manufacturing use case, we use again the AR glasses, but we also use a stylus to guide the robotic arm. In red, you see in all 3 slides, you will see in red, these are basically the partners that came from the first open call. So in the first open call, we onboarded 4 partners that helped us extend the use case environments. And then we had a second open call where we onboarded partners that actually brought new use cases into the project. So relation to standards and standardized or reference quote unquote architectures, this was a consideration for us from the get-go. We did believe and decided it was necessary to define, let's say, our own architecture that, as I said, highlights the 3 capacity pillars, the 3 key areas of focus of IntelliOT. But we did study the alignment and verify the alignment of architecture with other architectures. One aspect that was influenced us a lot was the W3C Web of Things approach. Basically, in practice in IntelliOT, all services are the capacity of all services are modeled in W3C Web of Things thing descriptions. The actions themselves are exposed as affordances that agents can assign tasks to the underlying infrastructure. There is the University of St. Gallen is working a lot on that, and Simon Mayer is also very actively involved with W3C Web of Things community. We also studied our alignment with other architectures. Here you see our alignment with the IoT high-level architecture, with the IIRA reference architecture, and it's in different domains. We have this in, if someone is interested to learn more, we have them. I can point to the architecture deliverable where we do this analysis in more details. Here you see the EDGE taxonomy that was proposed by the IDC and the European Commission. And also on the bottom right, you see the different use cases, that cover, basically focus on different subsets of this taxonomy. With regards to contributions with standards, sadly, none of my colleagues and partners in IntelliOT that works actively in some of these areas was here. I'm mostly involved in the security aspects that I will mention in the next slide. But basically, we on the 5G and 3GPP front, we had significant contributions by Eurecom, of course, who is working closely with the 3GP community. There were contributions on 3GPP RAN core and application work items that were closely related to the different use cases of IntelliOT. Basically, to be accurate, the agricultural use case and the manufacturing use case relied mostly on the 5G technologies and for example, 5G MEC infrastructure and so on. But in use case 2, the healthcare, since we had this, let's say, public 5G network that is on the mobile phones that we give to the patients, we didn't actually focus on, potential improvements there. There were also contributions on the 3GPP RAN. In IoT, we presented the IntelliOT use cases, and we also made contributions to the IoT landscape maintenance and standardization task force. The open air interface, this is a Eurecom, let's say, development that was also quite a bit, let's say, promoted in the different standardization bodies. And then moving to the W3C Web of Things, this is another area where we had significant contributions in the use cases. The IntelliOT use cases were listed in the Web of Things use cases that you see in the link there. Supported the creation of tooling and libraries around the Web of Things description. Also proposed some extensions. You see in the bullets here, like the models for late binding, for journaling, and so on. There actually, Sangallen was a key contributor for the creation of the W3C community on autonomous agents on the web. Riding, let's say, on the developments that we did in IntelliOT. And also myself, I'm mostly included in the last part you see here about the OASIS Cacao specification. Cacao is basically a specification that is in the process of becoming a standard about collaborative automated course of actions. You use it basically to encode security, for example, incident response actions. And one of the tools that we developed was actually one of the first commercial tools, basically, to use this specification. So as you understand, there was a big interest from the technical committee of Cacao, and we provided some feedback, and that helped inform the latest releases that are now live and on the way to become a standard. And of course, we participated, as you know, we've seen, your projects as well, and the IoT thematic workshop, EU IoT activities, and so on. Yeah, that's it from us.
Thank you very much. I don't know if someone has any question, comment, something. Okay, thanks again, Konstantinos. And now we can proceed with Anna from 10 minutes.
Jens, would you like to go first so as not to delay any further, and I will present after you? Is it okay?
If you like, I can do this.
Yes, thank you very much.
Jens, you are now presented, so you can proceed.
Okay. Let me try whether sharing works on my side. So, can you see my screen?
Yes.
Okay. So, yeah, as you know, I'm not at my office, so I will not see the chat or any shared, raised hands or something during presentation. So, just interrupt me if that's okay. That would be great. Okay, then I will just start. So as for the other projects, I will quickly introduce EdgeCloudIoT and then focus on, let's say, the standardization aspects as well as let's say the exploitable assets, or let's say what from our point of view might be relevant for the presentation today. So as you know, EdgeCloudIoT is short for very efficient deep learning for IoT. It does not only focus on the different use cases that we have in the project, from industrial IoT, automotive, and smart home, but we are also building, or we are having a focus on the hardware platform in a sense that we have developed a scalable, heterogeneous, distributed hardware platform which embeds accelerator and also a tool chain for optimizing the different neural networks that we are then using in the use cases. So from that perspective, EdgeCloudIoT is maybe a little bit different than the other projects that have been presented before. As I guess also most of the project EdgeCloudIoT is going to end of the month, so same schedule basically as for the projects which has been presented before. We also had 10 open calls, which we had in the project and which are already finished. They were running for about a year, and they were basically the first adopters of EdgeCloudIoT technology, and we presented the outcomes of this in a dissemination event in Amsterdam in October last year. So this is what we call the EdgeCloudIoT big picture. We have the hardware platforms here at the bottom, covering the complete range from far edge, near edge to cloud. And yes, on top of this, then we have the different microservers which go into these hardware platforms. As said, EdgeCloudIoT has a specific focus on these hardware aspects. Then we have the middleware with the tool chain, the emulation, and the deployment parts, and the use cases on top. This is then, let's say, here in the verticals added by, on the one hand, the safety and robustness mechanisms, as well as the modeling and verification techniques, and for sure the security mechanisms here, for example, trusted execution or specific RISC-V extensions. For the hardware platform, the idea was basically to create what we called a EdgeCloudIoT cognitive IoT platform, embedding all sorts of different technologies in one, let's say, scalable, modular, and heterogeneous hardware platform, so that you can easily combine, for example, GPU computing with specialized FPGAs or a standard x86 service. That's what we did, and we developed this range of hardware substrates here in the project, as said before, covering the far edge to the cloud in one dimension, so to say, and then having all those different microservers here in the other dimension. So really, as you can see, covering traditional CPU-based x86 ones, the FPGA ones, the ML ones, for, let's say, the far edge up all the way up to the cloud. So from a standardization perspective, this let's say, all looks now like a big mess. So one of the key standardization activities in EdgeCloudIoT was let's say engaging with existing standards. ComHPC, developed by PicMic X, is such a standard. And within EdgeCloudIoT, we actively engaged with the work group of ComHPC. As said, we had weekly meetings and basically defined or extended the computer on module standard defined within ComHPC. I was one of the editors of the specification. As said, it's a computer on a module standard. It is driven by industry requirements. The work group composes companies like Intel or Advantech or AD-Link or Seco and Congatec, for example. And it basically defines all the things that you require to design such a computer on module in order to then really be able to create on the one hand scalable, on the other hand open, and on the let's say next stage reusable computer on module form factor. This is for, let's say, quite powerful modules, so you can populate let's say also server on modules there, for example, embedding the latest Intel Xeon processors, for example, and we have developed in the project, we have developed modules ourselves based on ComHPC, integrating, for example, then latest state-of-the-art FPGA SoCs in there. If you go then more to the, let's say, lower or let's say low power module or smaller module form factors, there is SMARC, and there basically EdgeCloudIoT did the same. We have been part, or we are still part, and we will continue to do so, be part of this work group, and basically did the same thing, but for a smaller form factor. And within EdgeCloudIoT, we also developed a SMARC module specific for MLX acceleration. So this is then one aspect. Another aspect that might be interesting is that we did a quite extensive benchmarking campaign within EdgeCloudIoT. Here you can see basically a continuum of different accelerators. On the one hand, here on the one axis, you can see the power consumption and the performance, which is then clustered into, let's say, ultra low power, and high performance. This is scaled in a logarithmic fashion here, so that's the, let's say, from, for example, this one's here to just a simple Jetson TX2 or so. There's quite a large gap. Some things that, when doing such benchmarking, some things that you experience is that it's quite difficult to really do this in a way that it's let's say transparent and reproducible across all the vendors, because you need to deal with different tool chains, you need to deal with different devices, you need to deal with lots of different things, and to make this comparable, it's not that easy, so to say. This is here an example where we have used our YOLO V4 network. We did the same thing for other YOLOs, for example, V7 or with ResNet and EfficientNet across the different devices here, from a normal CPU one to, for example, a Halo 8 or a big or a very big GPU. So as said, doing this in a way that it's really, on the one hand fair, but still, let's say, involving all the different tool chains from the vendor, you need to have some tools for that, and that is what we did in EdgeCloudIoT. We were building this on top of the existing Renode and Canning tools, which are open source tools. Renode is for basically a simulation of distributed heterogeneous IoT systems with a specific focus on RISC-V SoCs, but you can also use it for ARM. It basically integrates lots of devices, can improve test and verification, and was, for example, currently used in Google's CFU playground. And the same for Canning, while Renode is mainly active on the simulation side. Canning is basically gives you a hand when it comes to deployment and creating the runtimes for deep neural network applications. It can be used for automated benchmarking, and that's basically what we used and what you saw 2 slides ago. So that's basically a way to overcome all the, let's say, very heterogeneous tool chains and this wide variety of different hardware platforms which is available. Then when it comes to security, something that we did within EdgeCloudIoT is to enable remote attestation and a trusted execution environment within WebAssembly. So for the let's say well-known platforms like TrustZone or Intel SGX, we basically embedded this into WebAssembly, into a WebAssembly runtime, enabling security for edge and cloud devices. And we also worked on the remote attestation, basically adding a distributed Byzantine fault-tolerant attestation and configuration service within EdgeCloudIoT. So that's another, let's say, building block. Which we, as all this is open source, also see there for standardization, for example, in the RISC-V ecosystem. Something which, is not yet standardized, but might become important, and at least we see it like this, is framework architecture for development of AIoT systems, really spanning from all the different layers, like starting from the analytical layer or the conceptual layer down to the runtime, starting from the logical behavior, AI design, hardware, communication, or quality concerns. So really like a systematic way to design and also document and verify distributed AI systems, specifically in the IoT domain. So that's our proposal here. This is, as said, not yet a standard, and we are still looking into how this can be utilized and how this can be best distributed across the community. So in summary, standardization within EdgeCloudIoT, we had we did some work together with PicMic and SCAD in the hardware and microserver form factor domain, with active contribution to the existing standards. We did several open source contributions to existing large projects like Renode and Canning, or the RISC-V ecosystem, and the WebAssembly community. And because there was also the question for recommendations, this design framework for IoT and AI that was developed within EdgeCloudIoT, from our point of view, could have a impact on, for example, dealing or complying with regularity constraints, for example, the upcoming AI Act, which basically requires you to do the whole system design on the different levels in a, let's say, documented and reproducible fashion. So that's it from EdgeCloudIoT. Thanks, everyone.
Thanks a lot, Jens. I don't know if you have any comment, questions from the audience or the other presenters. Okay, thanks a lot, Jens, again. So we can proceed with Anna. Just a minute to share my screen. Okay, so you can see the screen.
Yes.
So Anna, the floor is yours.
Thank you very much.
Can you speak a little louder, Anna? Can you speak a little louder?
Yes, now it's better.
Not so for me, at least. I don't know about the others.
It's a little bit quiet, yeah, but I can still hear it.
Okay, I will try to talk loud. Apologies, I have some network delays.
Now it's better, okay.
Thank you for assisting in the presentation. The Terminate project, which stands for Next Generation Smart Interconnected IoT, consists of a consortium of 26 partners. So let's go to the third slide and see our consortium. We have 3 industries, 5 universities, 3 research centers, and 15 SME companies that assist in the implementation of the project. Now, the basic objective of Terminate, let's go to slides more, please. Thank you, is the deployment of a flexible, open, and decentralized next-generation IoT reference architecture, which is supported by security by design and edge AI technologies in order to foster new real-time capable solutions. This is the main objective of Terminate. Let's move on to the next one, please. Now, in regards to business logic and the technologies that we utilize here, the integrated platform of Terminate actually provides an open programmable and agile network fabric by using the SDA technology, which is complemented by a federated learning framework so as to train decentralized data on privacy-preserving manner and move then all of this information towards the AR/VR contextual framework that we have set up here, while in parallel preserving trust, privacy, and authentication qualities by utilizing a variety of security technologies, such as blockchain. Thank you. Now, the Terminate platform had to be evaluated through a variety of application domains in order to come through specific research results and to define all the different kind of requirements that we needed towards the deployment of the application. We had to evaluate the platform through various use cases. The first one was testing it through a smart farming application. We also had some findings through our 2 healthcare use cases. We had another one with a smart, sustainable, efficient building, and 2 industry use cases, the one focused on supply chain in dairy products, and the other one in fault prediction procedures of IoT-based critical infrastructures. Thank you. Now, in this slide, you can see the overall concept of the Terminate project and how the Terminate platform fits from an architectural point of view in the IoT edge-to-core cloud continuum, actually. So what we can see here is at the lower layer, we have the different infrastructure domains that were deployed in the duration of the project, implemented in the project. And we have a variety of data that come from the access domain, the edge domain, and the core domain, and moved forward to the Terminate platform through a variety of services, actually, according to the domain defined. And we have also information coming from the IoT vertical stakeholders layer at the upper top of the figure, and everything comes together in the Terminate platform. Now, the platform, despite the using the federated learning framework and the software-defined network fabric, also deploys streaming analytics techniques in order to support the variety of the data that come from heterogeneous application domains, and also the different kinds of IoT hardware that is required to support the applications. We can move on. Thank you. And just to go a bit deeper on the definition of the architecture, since our main purpose here is to define a reference architectural model, In Terminate, we have at the bottom, as you can see at the figure, the various heterogeneous IoT devices that comprise the physical layer. Now, this kind of hardware is integrated with Terminate through the access network, which Terminate equips with SDN features. This is the middleware layer, actually. And it does that in order to programmatically steer the IoT data towards specific parts of the Terminate platform. Now, the platform itself comprises of physical and virtual nodes as well that span across the edge and the core data centers over the continuum. And that is actually the reason why the Terminate platform layer that you can see here in orange is an umbrella layer, let's say, that hosts the middleware layer on the southbound side towards the devices actually, but also the legacy and the intelligence applications towards the northbound side, which is the user-facing side. Also, across the entire Terminate platform, you can see in purple color, is the vertical layer that undertakes the security, privacy, and trust mechanisms, which are actually the key to ensure the hosting of applications on physical and virtual devices through distributed agents that offer device attestation services to Terminate. And in order to coordinate everything, the key mechanisms of the platform require the definition of an essential set of control plane components that are responsible for coordinating the data storage, the management operations that come from the various Terminate applications. The deploying also and the orchestration of the Terminate applications is done through the vertical application orchestrator, as you can see here. While the data storage that I mentioned is done through the streaming analytics orchestrator. And we have also have management of the network services from the ATN controller, and also the control of the various security mechanisms. All of these components and operations define the Terminate minimum platform profile, which we use vertically in all of the use cases in Terminate. This is actually the key component, set of components that are essential to provide all the applications that was promised in the various use cases. Also, as a part of this MPP profile, we also include an intelligent layer component, despite the fact that this is actually an application component, not a Terminate platform component. And this component is the federated learning inference at the edge. And according to the use case, this component is based either on a centralized federated learning approach or a decentralized one. In Terminate, we have two federated learning approaches, which actually complement the needs of each use case according to how they are utilized and what we intend to accomplish through the use case. And last but not least, another important component of the platform is an application component, is the general dashboard component, which actually visualizes helpful information that we want, such as measurements from the network, which are obtained from the vertical application orchestrator, such as deployed Terminate applications, or come from the data center SDN controller, for example, regarding the network fabric of the Terminate infrastructure. So this is actually how the profile is consisted of and how it works. We can move on to the next one. Thank you. So based on our research findings in Terminate and what we tried to accomplish through the various use cases, and due to the fact that not many of our consortium members were not connected with standardization bodies actively, we tried to level up our contributions in various existing frameworks, such as our contributions on SDN technology in various open source projects currently running, and also by experimenting on the emerging SDN technology entitled Arena, which is also part of the Terminet project. We have also tried to produce contributions regarding the federated learning approaches, and also use case specific contributions, such as the release of an orchestrator of intelligent UAV swarm based on our research in use case 1, a QR scanner for AR application in one of the industrial use cases, and also the deployment of APIs for virtual reality and augmented reality applications, and some more at the next slide that actually have to do with an experimentation on digital twin environments, different kind of also security testing. We experimented with Hyperledger Fabric technology, and we have managed also to define a prototype, to produce a prototype, Snyder's new generation of RTU device, as well as a patent on attestation technique. We have also released a part of our middleware IoT platform that we use, Terminet, in Terminet, and this is actually most of it in terms of standardization, actually. But except these action points, I would like to highlight that one of our major achievements in Terminet was that we managed to produce a number of public data sets from the experimentation in the use cases. Yes, thank you. To do that, of course, we had a large number of scientific publications, and here are our datasets, which can be found in the Terminet website. We have managed to produce more than 6, I believe, from all our use cases in Terminet. We have a cherry tree disease detection dataset and a peach tree decision dataset from our smart farming use case, one coming from the smart health use case, another one from including virtual reality gesture recognition from our supply chain use case, and also some measurements from the smart house use case. So this is all, I believe. Apologies for the interruption before. Are there any questions?
Okay, so thanks, Anna, for the presentation. And now we can proceed to the last presenter. Let me make him a presenter. I'm sorry from the pronunciation of the name, is Zbigniew.
Yes, hello, Zbigniew speaking. Okay, you can make me a presenter.
I already did it.
Okay, I will share my presentation. Okay. Just to check, you see my screen?
Yes, perfect. You can proceed.
Okay, thanks. So I'm Zbigniew Kopertowski from Orange, Poland, and I'm representing ASIS IoT project on this workshop. So I will show you our involvement shortly. First, our technical solution, and mainly also to discuss or to show our involvement in the standardization activities, how we contribute and proceed with the standardization work. So in ASIS IoT, we specified the reference architecture that have as mainly commonly with other architecture like in OpenFOC or IoTi high-level architecture. We are aligned, so we have planes and verticals. So in the So it is multidimensional approach which we implemented based on microservices of containerization and enabler abstraction. Our main concept was to make enablers and put them in different verticals and planes. Whole platform, whole our solution is based on the Kubernetes, so our enablers are packaged to the Kubernetes and Dockerized, so can be run smoothly on the Kubernetes. So we have here you can see now what we developed in the architecture. Totally, it is 41 enablers, different enablers in different, let me say, technical areas, technical domains. You can see in the verticals, which is manageability, scalability, security, interoperability, and self-start. It means self work, automatic work of some functions. We gather different enablers. We develop different enablers based on and we make this put them in the verticals. So it is these verticals are they're crossing the planes, which is typical planes in the architecture, like starting from above is application and services plane, data management, smart network and control plane, and at the bottom device and edge plane. So you can see, I will not say in details about each of the enablers, but we have what we have, for example, federated laning enablers regarding security and privacy, different enablers. So this is different function that can be run on and used in our platform. And in the planes, you can see, for example, our main achievements was the IoT gateway called Gwen. So it is also based on the there is a possible to run this on this device that was developed and designed from the scratch in the project. You can run also the cloud functions, virtualized. It is virtualized solution. Also, then we have in the control plane, we used also SDN, but for us typical SDN controller. But we also have as a main achievement is the smart orchestrator that is using that manage all the virtual resources in our platform, and then different enablers related to the networking. Also in data management plane, we have a semantic translator repository, and main is Edge data broker for the data management. And then we have different application, which main also can be tactile dashboard that we can see the dashboard of the result of the different application, how it works, what are the KPIs, etc. So this is a quite complex, as you see, quite complex platform solution. But in terms of the standardization work, we have a possibility to touch also, as you see, different technical subjects. So it was quite large opportunity to work on different topics also in the standardization. And such solution, this platform, of course, we deploy in the 3 use cases. One was port automation, and second was smart safety of workers, and third one was cohesive vehicle monitoring and diagnostic. When we look at these use cases from the standardization work perspective, also we can here we have some activities that are specific, use case specific. I mean that, for example, for smart safety workers, there are special also we contributed to the specific standards that are only related, for example, to the safety on the construction site, in the industry plant. So just as an example, so the work on the standardization, the project, of course, is related as usual to the technical work, to the different subject that we are worked, but in our case, we have partners that are members of different SDOs, so standardization organization, and also participate in different initiatives like IoTI, BDVA, ESCO. We have active participation in IEEE, ITUT, also in EdgeCloudIoT. And you can see here in different technical areas, domains, like let's say general IoT, AI, networking, cloud, and cybersecurity. We made some contribution, or we are actively participated in some work, but of some of them we can just follow. So it is typical approach, I think, but in our case it was possible as we have a few partners that are participant in different standardization organizations. So the main technical domains that we are worked on some contributions, because we are not developed from the scratch of course the standards, just as usually it is contribution to some subjects. So we made for the IoT architecture, on IoTI high-level architecture, on edge computing it was contribution to EdgeCloudIoT. We are used, of course, Kubernetes, open standards, EdgeCloudIoT, NVIDIA, and Mano for our solution. So it is not, of course, we try to contribute, it is the main, but also in the developing of the project, of course, we are applied some existing, of course, the standards. So this is the main which I here pointed out. So in the pilots, it was last period, it was many opportunities also to put the requirements from the pilots, from the use cases, and specific functionalities as for example, in EdgeCloudIoT we put to the human interfaces of AI human interfaces as a base for and our contribution was the description of the use cases, for example, the requirements and functionalities as a base to prepare the final standard in EdgeCloudIoT, for example. So this is the way which it's, for me, it's the easiest way to utilize the project results and make some contribution to the standardization work. Also in different areas like data management mainly, and also in cybersecurity we made some contributions. So to summarize, we supported applied standards in the architecture. You can see different organizations, but mainly it's EdgeCloudIoT. But we are also support applied open, like support OpenFOG, IUTI, ITUT. And in IoT use cases, we contribute to the ITUT. They are working on different even use cases specification. In HCI, also it was about the use cases requirements. And also we are applying different, it is sometimes it's, I think it is automatically that we are using the in our solution, but in development of hardware, typical standards that we need to deploy. So also we are following support the W3C web standards, different standards. And as I mentioned, to summarize, we made already some contribution to IoTI, mainly to the technical reports or white papers, to the standards also and technical reporting in HCI and ITUT. In the use cases, as I mentioned, in the data area and security in the ESCO, it is also white papers. So our work for the standardization is related to the contributions that are can be used later for the preparation of recommendation. It is hard, of course, to during the project period make the full, let me say, recommendation in some standardization case. It is not possible, as you know. It is long-term work usually. So that's all that I try to share with you how it's in our case looks the standardization activities in our project.
Thanks a lot. I don't know if you have any comments, questions from someone. Okay, I don't see any questions. So when preparing this workshop, along with Anna, we have made some, we have prepared some questions. So let me share my screen. In order regarding the next steps, just a minute to share the right screen. Not this one. Okay. Okay, so we are on time. So let's go through some of the questions if we can provide some answers. Let me again show. So I will go with the first one. So the first one is about, based on your research findings on the distributed systems, if you have any recommendations on how we can better define another architectural model for the edge cloud IoT continuum. I don't know if someone wants to initiate the discussion.
Well, maybe from my side, this is Jens from EdgeCloudIoT. On my slides, I was talking about this, let's say, not the reference architecture, but let's say, framework to design such systems. So that could maybe be a first step into this direction. So this compositional architecture framework for AIoT, that's how I called it, I guess, could be something that fits maybe.
Okay, so if I understand correctly, you have provided this framework that can be used in order to design this let's say, architectures.
Yeah, because it's exactly let's say like a systematic approach to design such a thing.
Okay, thanks a lot, Jens. Anyone else? Any view on that? Do you think that what Jens proposed is something that can be used probably, or any other comments that you might have?
Yes, I think this also applies in our case as well for Terminate, since as the definition of an architectural model is actually the composition of the components required per architectural layer, if you can see it that way. And its composition is actually the components and the services required on the basic operations. And this is actually the work that we are trying to accomplish through our participation in the EU EdgeCloudIoT Continuum as well, where we are trying also to define an architectural model for the next generation IoT. And the main focus is on specific technologies and tasks that need to be existent in such models, such as the security aspects, the AI aspects, such kind of stuff.
Okay, thanks also, Anna. Anyone else?
I would add something complementary to what Anna just said. That would be instead of focusing on specific technologies, more on the opposite, like considering what I said in my presentation, that the IoT devices are following different protocols and not all of them are compatible. So actually considering that it's necessary an abstraction layer that is able to translate among these protocols to be able to communicate among them.
Okay, yes, thanks, Nuria. Yes, this is something that is missing. Okay, there are a lot of protocols that not interact together. So this is something that it's definitely needed.
Exactly, and we were doing that in Ingenious actually.
Okay, thanks a lot. Anyone else? Okay, thanks a lot. Let's proceed to the next one. Let me. So it's okay. I think we have covered this, but okay, let's take a wrap up on this. So let's go again through all the project to, if you can say what was, let's say, the major impact that you consider, not all the contribution, regarding the major impact regarding standardization that you think that your project have. Should we start from the same order? Nuria, do you want to start first? Or I
Sure.
see. Okay, yes, thanks.
Okay, so I mean, we contributed a lot to the RAN working groups of 3GPP, but also we have done some key, let's say, contributions to satellite connectivity standards. And that's something that is already being studied for 6G, which was not fully integrated. So I think that would be also a key achievement.
Okay, thanks. Ilka?
Yes, I think it was referred several times that when you actually do standardization work, you need time and you need the connections. In our case, like I said, we were successful in actually getting the actual global standards in place due to the fact that we had people in the right working groups. But at the same time, even more crucial was the fact that there were actually client cases that were supporting the standardization activities. And so the demand side was actually helping us in getting the 5G standardizations in place.
Yes, I agree. You have to have the correct, the right players, the right stakeholders in order to push things towards standardization. And the second thing that you mentioned, it's also important. If there is no demand, it will take a longer time, or maybe it has no meaning. So if you also have the demand side, it will help. Okay, but as you said, the first thing is to have the appropriate stakeholders. We have seen it in many projects that have very good work, but due to they don't have the right persons, it's difficult to start to do something standardized. Right? Okay, thanks a lot.
Yeah.
Konstantine?
Yes, hello. Yes, from our side, I would say, of course, we had significant, let's say, involvement and adoption of latest developments in 3GPP. But in terms of, again, of course, this is due to the, to the composition of the consortium. So we had, for example, Eurocom who are very active already there. So it's not that, nobody knew them in 3GPP and they did something amazing in IntelliOT and they contributed. They already were working on some things. They had sort of an agenda on things they interested them. We tried them in IntelliOT and we gave feedback to 3GPP. And the other one would definitely be the W3C Web of Things working group. because again, by inception, some of the components were definitely aligned to adopt, let's say, the Web of Things approach, and we both provided new use cases for the W3C Web of Things specification, but we also identified through the use cases and through this concept of autonomous and semi-autonomous agents that we tried in practice in the use cases of EdgeCloudIoT, we kind of provided extensions to a number of specifications within the Web of Things ecosystem. So these were probably the two areas where we mostly contributed. Again, of course, I agree with everything you said, that it's maybe you have something amazing. If you don't have already access to these standardization bodies and you're not already working on something, it's very hard within a time span of 3 years to have an impact, right? So that's very important.
Perfect. Thanks, Konstantinos. Let's go to Anna.
In Terminet's case, I believe that our major contributions was in a use case level, actually, because we managed to push one step forward use case specific technologies and projects that were going on through Terminet. I could also highlight our work in SDN technology. We have also some major contributions there, as well as the prototype that we did for the RTU for use case 6. Also, the work done in the smart farming use case with the AR glasses. It's another one of our major achievements. And yes, last but not least, the datasets. As I said before, there was no involvement with major standardization bodies here, but in overall, towards the definition of the architectural model, I think we try to cover any kind of technological gaps at the time.
Thanks a lot, Anna. Let's go to Jens.
I consider the work that we did on the hardware side, so the different form factors, as probably the most relevant one, at least the most visible one, so to say, because the other contributions that we did were, let's say, to bigger projects or things, so to say, while the COM HPC is something which, on the one hand we worked a lot, and on the other hand it's basically one piece, and it has, let's say, high industrial relevance.
Perfect. Thanks, Jens. And last to Zbigniew.
Yes, so as I mentioned, and probably can be similar to what said Anna, that our impact was mainly by use cases, because there was we have this opportunity that we have active partners in HCI, ITUT. So there is ongoing work that we could join, and they look for requirements, specification of the use cases that was base for the build some standardization recommendation or in the future, of course. So it was just contribution, but it was the impact also. I think on the architecture in IoTI we are working actively. So it is in edge computing and IoTI it was different reports there. So they coordinating and the IoTI also give opportunity to collaborate with different SDOs also in the forum. So it is impacting too in the use cases, based on the use cases and in the architecture, I think.
Perfect. Thanks a lot. Let's go to the next of the questions we have prepared. So the next one is if you have any plans regarding the exploitation of the architectural models that were defined in your projects. I don't know if someone wants to start or we should take again around. Can you start again from the beginning from Nuria, if you have something to add?
Sure. I mean, our project finished almost 1 year ago. So our plan would be like continue working with the key partners on that because we have done an amazing job and it would be like a pity not to move forward and keep building over that. So that would be actually our goal.
Okay. So we have an upcoming question about how you plan to continue. So you plan to continue the work with, let's say, in some new projects or?
Yeah.
Okay. Do you think that, okay, there are some cores that can help or something that is missing that need to push, let's say, towards EU in order to help us continue this work or something like that? What are your opinion on this?
Well, yeah, it's continue looking for calls where to apply with the partners and yeah, keep building this ecosystem and keep doing these workshops we're doing so we keep interacting because actually I'm here, but typically when a project finishes, then we don't attend to the workshops and so on. So we keep pushing this to get this community moving forward and not throw away all the achievements we have done because it's a lot of money invested, a lot of efforts from all the partners. So we want to build over that.
Yes, it's important, as you said, when the project finishes, okay, it's difficult to proceed, but the building of the community is it's very important, and especially if you have good partners that you can collaborate and communicate with them. Thanks, Nuria. Ilka, do you want to add something? What are your plans regarding the exploitation?
Yeah, since I was kind of leading the exploitation activities with an IoT engine. So the idea was that during the second phase, when our models and components started to be mature enough, we had a very specific goal to actually take the good parts from our project and actually integrate those with member state funded national initiatives. So that's ongoing. And the other thing was this direct feed to the industry plans. So that some of the individual companies are now adopting models from our side and they are integrating them into their commercial offering. And I think that work continues. And as long as there is demand, again, we will continue that even if the project itself is not continuing anymore.
Yes. That's good approach that you've mentioned also. Okay, not just the EU fund, it's also the national funds that can be used in most of the cases. Okay, but we usually forget about this, but this is also an approach that must be taken. And I don't know what happens because the framework in the different countries is not always the same, and it's not actually easy to apply in all of the countries. Maybe, I don't know how we can better see this sort of cases, but okay, thanks a lot, Ilka. Let's go to Konstantin regarding your project, Intel IoT.
Yeah, basically our exploitation approach was mostly focused on the framework as a whole and not on the architecture or model itself. Our intention from the get-go was that, okay, we propose our own architecture where we try to align it with existing reference, quote unquote, IoT architectures. Because I mean, there are plenty of those and they're probably underutilized. So to come up with an additional architectural model, you need to be very confident that there is a gap that you're trying to address. And from our work, this did not come out as the case. So of course, we do plan to pursue further our concept, but it's not, the novelty does not lie so much on the architecture itself, but rather on this interplay between the three pillars that I mentioned before: collaborative IT, human in the loop, and trustworthiness.
Great, thanks a lot. Anna, you want to, what about Terminate?
Yes, for our side, we saw that there is a lot of potential in the use case specific exploitation activities actually, because we saw a lot of interest, especially in the smart farming use case with the application of the Terminate services and the platform itself, as well as in the healthcare ones. So the main goal here, of course, is to continue the collaboration on these application domains with the partners involved in the use cases, and we will also try to have a more active role in the definition of something further for the architectural model of the platform. So this will be basically the two aspects.
Okay, thank you. Jens, for EdgeCloudIoT.
Sorry, I had troubles with unmute. So regarding the architectural models, we are active in the EU Cloud Edge IoT initiative, building this reference model, which is ongoing currently with lots of different and other projects. Regarding the framework architecture that I was referring to before, I pasted a link to our publication in the chat, and there's also a software framework which is we have a first version of it, and there's high interest in especially the automotive industry, so from companies like Volvo and Magna in this activity. So this is also, let's say, one exploitation of the project regarding, let's say, the architecture per se. Regarding the hardware architecture, for sure there is individual exploitation from the different partners, obviously, as well as for the different use cases that we have in the project. So they will also, let's say, live on and will be exploited by the individual partners of the project.
Yeah, great, thanks a lot. And last, Zbigniew.
Yes, so quite similar in our case, I think, because we have companies in the project that are especially interested, and already they have pilots, like in the port in Malta, like in a construction site in the construction company in Poland. In Orange, like me, I'm from Orange, we have a IoT platform that we are also implementing the IoT services and selling. So this architecture and different enablers from the architecture, we just, for example, for safety of workers also we could apply. So it is mainly, I think, the exploitation and all the findings, outcomes from the project and from the architectural models are utilized by the partners of the project mainly, for sure. And it is quite related to the use cases that we had.
Yes, I think it's important to have big industrial players and also to have some solid use cases where we can show the benefits of the solutions developed. It's always easier that way to exploit the result of the project. Thanks all. Let's see what next we have prepared. Okay, I think this is I think Nuri already answered all this. It was if you plan to continue the work in the project, for example, in some other projects, I think also Ilka mentioned that they plan to continue the work in some national projects. I don't know if someone else wants to add something regarding this question. I think more or less it was answered. My comment when try to continue this question is to identify if there are any bottlenecks or something is missing that prevents the continuation of the work that has been implemented in the projects. I don't know if someone wants to add something here.
Maybe Zbigniew, one is the solution that we are providing in such project. This is mainly research project. implement, to deploy, and for commercialization, it is required another work later. So as you know, probably all we know. So it is good starting point, and many solution we try to later applied somehow, but it required some internal project in my company or external companies that will do this.
Yes. Thanks. Anyone else wants to add something? Okay, let's go to the next one. Okay, this is
There's I guess a hand raised.
Yes,
okay.
Ilka, nice, wait.
Yeah, just a general comment. Having been around on the EU projects for quite some time, as many of you as well, we should really stress from the outset of the project the demand side. So speaking as a business school representative myself, so really understanding at the same time when we start building the architectural models and then looking into the use cases, working from month one on who is actually going to use it and for who it's for. And I do see in many of the EU projects, and it's not kind of a finger pointing anyone, but basically it's the fact that we do a lot of the exploitation work towards the end of the project instead of at the beginning.
Yes, I have the similar role in some of the projects of the exploitation manager and user case, but okay, I think most of the times it's difficult to start from the beginning because you don't actually know what is going to come out of the project. So this is like a chicken and egg problem most of the times. And as you said, it's important to have, when you define the requirements, to have players that are really interested, the stakeholders, even if better if they are outside the consortium. This will be even better.
Yeah.
Just because inside the consortium, okay, maybe biased, they know what they're doing. But if you try to attract people outside the consortium that are really interested in what is going to be developed, I think that's a very good approach.
Yeah, and in our project, we really engage with the advisory bodies that we had in order to kind of get a feedback from their side throughout the project as well.
How did you manage this, Ilka? Because we have tried in the past to approach similar a lot of bodies, but usually we don't get any response. They are not interested. They don't have any time. There are a lot of no's usually.
I hate to say it, but it's a lot about personal connections.
Yes.
So that we're able to really kind of get them engaged.
Yes, it's important. Thanks. Okay, anyone wants to add something? Okay, let's go. And let's go have a couple of minutes. If you have any suggestions regarding the next steps at a higher level regarding the EdgeCloudIoT Continuum, do you have any, from your experience, something that can help in order to not stop the work and have something that has a high impact? Any comments or suggestions on that?
Maybe a different question, sorry, from my side here. This is Jens from EdgeCloudIoT. As we're discussing about standards and we see all the different organizations which are active in there. From the group here, what is your feeling? Which area is, let's say, covered quite well and which area is missing? So, let's say when we look at the different layers like the hardware, the interfaces, the software layer, the distribution layer, and so on, runtime layer. So, do you see something, because as you know, we are mainly active on the hardware side of things. Where do you feel are the biggest gap which needs to be closed in future? Any opinions in this round here?
Yes, Ilka.
I spent quite a long time in the telecommunications industry, and in there, this kind of a working together approach. So Ericsson, Nokia, Samsung, the Orange guys, at least they understand it. So there was a very much of an agreement on what are the things that we need to do together in order to make the impact and in order to kind of have the real kind of a joint effort there. And I do see now in the IoT and the AI and also in the data space discussions that a similar approach is kind of a slowly building up, and people are really learning that what are the key things that we can do together, and then in the end you do your own marketing stuff and then all that. But that takes time, and basically the more evidence that you have that it's needed for outside of the telco world to have a similar approach, then I do see that there is a more kind of a better way of really contributing not only the standards but really on the best practices as such. It takes a bit time and it takes building the trust between the players, but I think technology-wise we are covering, I think, the relevant things, but we just need to learn how to do things together in the right way.
Yeah, that makes sense. Yeah.
Anyone else on the question that Jens raised?
Just to add on what Inga said, that and based also on Jens' question, that we need also to learn to reuse stuff that we have already developed and then work together on them as a next project. This was actually a point raised in our previous workshop as well, where we mentioned that it was mentioned that when a project finishes, then it gets out of the way, and then we'll move on to the next one. But I think that should be a connection between the evolution of what we are doing in different application domains and technology-wise as well, and learn to work together at this specific stuff that we might have already developed together in a previous stage. Because I don't think an area technologically is missing something. I was trying to think something based on what Jens suggested, but I think from what I have seen in the current projects, most of the ideas and technologies cover the challenges, but there is no core coordination amongst the projects.
Thanks, Anna. One more comment before we close this workshop. Anyone wants to add something? Okay, so I would like to thank you all for participating to this workshop. Me and Anna will contact you to gather all the presentations and upload it firstly in the terminal website. Also, we can share it with you in also if you want to upload it in your websites. Anna, I don't know if you want to add something.
I would like to warmly thank everyone for participating today. I know it was a bit brief organizing everything, but thank you for being so responsive. Also for the projects that have already concluded their efforts, but we were glad to hear from you as well. This was our joint cluster, so it's nice to finish it together. So thank you everyone for joining.
Oh, thanks a lot. Enjoy the rest of your day, and again, once more, help you for your presentations and mostly for the discussion.